Next, number 8. Here, star is the binary operation defined by this equation. Binary operation on the set of natural numbers. For two natural numbers a and b, a star b is the greatest common divisor of a and b. Is star commutative? Is star associative? And does there exist an identity in N for star? Star is definitely commutative. For any two natural numbers a and b, a star b is their GCD, but that is also equal to the GCD of b and a, so that is b star a. Star is also associative. To prove that, we take three natural numbers a, b and c. Let m be a star b star c and n be a star b star c. We will now prove that m is equal to n. Let's first look at this equation. M is equal to this means what? M is the GCD, the greatest common divisor of a star b and c. Divisor after all, that means it has to divide both a star b as well as c. Oh, and one more thing, here I am using that notation, this vertical bar, to mean divisibility that we have already seen in the solution to another problem. Now from m dividing a star b, we next get these two things. M divides a and m divides b. Why? Because a star b is by definition the GCD of a and b, so it divides both a as well as b. And m divides this, so that's why m also needs to divide both a and b. Now we combine these two things, m dividing b and m dividing c. These two things imply that m divides b star c. That is because, what do these things mean? They mean that m is the common divisor of b and c. So m then has to divide their greatest common divisor. It's a property of GCDs. And then similarly, m dividing b star c and m dividing a imply that m divides a star b star c, which however is n. So we have found that m divides n. One can similarly prove that n also divides m. So we got this by starting with m. So we could have done a similar thing starting with n. That would give us this other relation. Now you combine this one and note the fact that m and n are both positive integers. Because of that, m is equal to n. And this is what we wanted to show. So this proves that star is associative. And finally, we come to the question of whether we have or don't have an identity. Suppose there is an identity E in N for our operation star. Then by the definition of identity, for all A in N, A star E would be equal to A, because E is supposed to be the identity. So when you take the product of A and E, product means A star E, I am calling that product, then A won't change, A will remain A. However, A star E is the GCD of A and E. So in particular, it divides E because it's the common divisor of A and E. So it's the divisor of A and E means it divides E. But that is A, so A divides E. But this should happen for every positive integer A. Now there exists no positive integer E which is divisible by every positive integer. And that is why this is not possible. So our supposition must be wrong, which just means that there is no such identity for this operation. And here the solution ends. Next, number 9. In the following, star is the binary operation on Q, the set of rational numbers. There are some parts. We have to determine if star is commutative and or associative. In part 1, this is the operation. A star B is A minus B. Note that it's a legitimate binary operation. For two rational numbers A and B, A minus B is a unique rational number. That's also the case with the other parts. We don't have to decide if it's a binary operation. It will be a binary operation. We have to decide whether it's commutative and or associative. The operation is neither commutative nor associative, as you may have already guessed. It's not commutative, that's pretty easy to see. 1 star 2 is 1 minus 2, which is minus 1. whereas 2 star 1 is 2 minus 1, which is 1. They are not the same. And for associativity, we just arbitrarily take anything, say 1, 1 and 2. This combination of the product gives us what? 1 minus 1 minus 2. That means minus 2. Whereas if you consider 1 star 2, then you get this 1 minus of 1 minus 2, which is 2, and they are not equal. Number 2, here a star b is a squared plus b squared. This star is obviously commutative. For any two rational numbers a and b, a squared plus b squared equals b squared plus a squared. That's why. But it's not associative. At first glance, it seems like it should be associative because you have plus. But don't forget that this is not ordinary addition. You have squares also. And it turns out to not be associative. Again, you take 1 star 2. What is this 1 star 1? 1 squared plus 1 squared. That means 2. So now you have 2 star 2. 2 squared plus 2 squared is 4 plus 4. That is 8. Whereas if you consider this other combination, 1 star 2, here you have to calculate 1 star 2 first, which means 1 squared plus 2 squared. That is 5. So you see that everything is now going to change. And then this one is 1 squared plus 5 squared. That is 26. They are not the same. Next part 3. Here a star b is a plus ab. This operation is also neither commutative nor associative like the first one. Let's calculate 1 star 2. 1 star 2 is 1 plus 1 times 2 or 1 plus 2, which is 3. Whereas 2 star 1 is what? 2 plus 2 times 1. That means 2 plus 2, which is 4. So not commutative. And then again you calculate this 1 star 1 star 2 and 1 star 2. There is nothing special about this 1, 1 and 2. Okay, you can take just about any three numbers. It is most likely that you won't get equality. So what is 1 star 1? 1 plus 1 times 1. That means 2. And 2 star 2 is 2 plus 2 times 2 or 2 plus 4, that is 6. Whereas this one, if you go through the calculation, there is of course no reason for me to say everything. You can see it for yourself. This is 4. So not associative either. Number 4 next. Here a star b is the square of a minus b. This one is commutative but not associative. Commutativity is almost immediate. For any two rational numbers a and b, the square of a minus b equals the square of b minus a. So commutative. But again, not associative. So this time I am not going to calculate the values. I want you to calculate these values and see that they are not equal using this operation, of course. Next, number 5. Here a star b is ab divided by 4. Star is obviously commutative because for any two rational numbers a and b, ab over 4 and ba over 4 are the same. Now this time the operation is associative, and to prove that, we take any three rational numbers a, b and c and consider this product a star b star c. A star b is ab divided by 4, star c is this number times c divided by 4. We need not even touch this denominator. In the numerator, we rearrange things. We write this product as a times bc divided by 4, which of course we can do. This entire thing, however, equals a star bc divided by 4, and this part is b star c. So that's why star is associative. And finally, number 6, where a star b is ab squared. This star is also neither commutative nor associative. For that, you can again go back to those same things. You calculate 1 star 2 and 2 star 1, you will see that they are not equal. And these two things also, you will see they are not equal. That's why.